Chemical nomenclature, the means by which we are going to actually name and talk about different compounds. We'll start with part 1, ionic nomenclature. Ionic compounds are those which form between elements that are high in their difference in electronegativity. In terms of broad span of this, the elements that are furthest apart on the periodic table from each other will form ionic compounds, and the further two elements are from each other, left to right, the more likely they are to form an ionic compound. Very often, ionic compounds are formed between metals and nonmetals, although this is not always the case. Ionic compounds can exist that are not metal and nonmetal. Ionic compounds form ions. There are cations and anions which form a charged pair, and cations are positive ions, anions are negative ions. The ionic compound itself does not form molecules, but groups of atoms that we call formula units. These formula units come together to form a crystal lattice, which is a large repeating arrangement of these formula units in a crystal formation. As an example of this, sodium chloride forms from the sodium ion and the chloride ion. They come together in a sort of hexagon shape, where you've got not hexagon, but a square cube shape, where you've got sodium, for instance. If you have a sodium atom at the center, you'll have 6 chlorines around it at what would be the ends of a coordinate plane, in a three-dimensional coordinate plane, if you picture that. Now, the properties of ionic substances, they tend to be high melting in their melting point. They tend to be electrically conductive if they are either molten or in solution. And they usually will dissociate in water. This means that in water they'll split apart and form their charged ions separate from each other. Generally, ionics as solids are crystalline in their form, and they are solid at room temperature. They tend to be soluble in both water as well as other relatively polar solvents. Types of ionic substances, we have the nomenclature of ionic substances is based on the type and the number of the elements in the ionic substance. If there are 2 elements, this is called a binary system. If there are 3 or more elements, it's called a ternary system. There are also different types of ions. We have monatomic ions, which are single atom ions, and polyatomic ions, which are multiple atom ions. The monatomic cations, so single atom positive ions, can be either type 1, which have invariable charges. That means that their charge is always the same every time. These are mostly the 1A and 2A elements, things like sodium, calcium, magnesium, but also some elements like zinc and silver, which are actually transition elements. Type 2 monatomic cations are variable in their charge. That means that they can have multiple different charges. These are mostly transition elements, things like iron, which can be either 3+ or 2+, copper, which can be 2+ or 1+, etc. So looking at different ionic nomenclature, we have binary ionic nomenclature, which there are type 1 and type 2 binary compounds. Type 1 binary compounds will be named by naming the metal first. So the name of the metal goes first, and then the root of the anion's name. So the root of the anion and the suffix IDE, or "ide", goes second. For example, sodium and chlorine forming sodium chloride. Sodium is the name of the metal. The element chlorine has a root chlor. So we take the root chlor, add the suffix "ide" to it, and get chloride. So putting that together, we get sodium chloride. Type 2 binary ionic compounds are named the same way as type 1, except that we have to include the charge of the metal because these type 2 are variable in charge. So for instance, iron can be 2+ or 3+. If iron is 3+, we call it iron 3. The 3 is in Roman numerals. Our charge will be represented in Roman numerals in parentheses in between the name of the metal and the name of the anion. So iron 3 chloride would be the name for this particular ionic substance. Common anion roots are things like ox for oxygen, sulf for sulfur, selen for selenium, phos for phosphorus, niter for nitrogen, fluor for fluorine, chlor for chlorine, brom for bromine, iode for iodine. Ternary ionic nomenclature uses polyatomic ions. It functions the same way that binary does, except that you substitute the polyatomic name in place of either the anion or the cation that it is taking the place of. So for example, iron 2 carbonate. This is the same way that iron 3 chloride was named, except now our anion is carbonate. Carbonate is just the name of that polyatomic ion CO3 2-. NH4NO3 is ammonium nitrate. This is a ternary ionic compound which is made up of two polyatomics. The cation and the anion are both polyatomics. NH4 plus is ammonium, NO3 minus is nitrate. The only common cation in ternary ionic nomenclature is ammonium, NH4 plus. Polyatomic ions also have classes that are called oxyanions. Things like carbonate and nitrate are oxyanions because they are anions that contain a large amount of oxygen. And oxyanions are polyatomic ions that have a high content of oxygen. They are classified as different families of oxyanions that are based upon the parent ion, what we call a parent ion. The oxyanion itself is a molecular compound. It's a molecule, but the molecule itself has an overall charge, so it's a charged molecule. There are a number of common polyatomic families that we deal with. There are carbonates, which are based on the parent ion carbonate, CO3-2-, nitrates, which are based on the parent ion nitrate, NO3-, phosphates, based on the parent ion phosphate, PO4-3-, sulfates, based on sulfate, SO4-2-, and chlorate, based on ClO3-. Oxyanions form families. What we call families are a series of different oxyanions that are all related to each other. And the name of the different components of the family are based on the name of the parent. They start off with a root, where the root comes based upon the non-oxygen element in the parent ion. So the name of the parent ion will be the element's root and the suffix ate. For example, chlorate. Chlorate, the non-oxygen element, is chlorine. The root of chlorine is chlor, so the name of the ion will be chlorate, ClO3-. All of the oxyanion families follow a pattern. If you add one oxygen to the molecule, the name becomes per, and then the root, and then ate. So adding an oxygen to chlorate would make ClO4-, and the name would go from chlorate to perchlorate. On the other hand, if I take away an oxygen, it will be the element's root and the suffix ite instead of ate. So again, with ClO3-, if I take away an oxygen, I'll have ClO2-. This would be chlor, the root, and then ite instead of ate. So we have chlorite for ClO2-. If I take away two oxygens from the parent, then I have the name hypo, the root of the parent, and then ite. So ClO3- without two oxygens becomes ClO-, and that would be named hypochlorite or hypochlorite. The families all have the same net charge throughout the family.